Okay, so this is the free fall lab. You guys already found your acceleration, yeah? So that was between like 30 and 100. And what's the units?
Meters per second squared.
Okay, now today, and some of you know the answer to this because either you took regular physics or you just remember it from like 8th grade. Okay, so don't say the answer, but today we're going to figure out how many meters per second squared gravity is. All right? See, I told you. Okay, don't say it. All right? We're going to test it. Okay, I don't want you guys to be trying to get a certain answer. All right, I want you to kind of go into this blind and then see what gravity's acceleration is. And then we'll do a percent error because I'll tell you what it is, or you can look it up right now on your phone if you want to. But don't do that. Okay. So we're going to use the same procedure as last time. We are just going to use the spark timers. All right? So come over here and get a Sparky. And I'm going to leave all of the spark tape up on the front desk. I would recommend using the metal meter sticks that are in the back because the ends of these are getting kind of rounded. Yeah, they're kind of beat up. So I would use one of those metal ones. And just come up here. And we're not going to do a Mr. Hicks half wingspan today. We're going to go a little bit more accurate and just kind of lay it out on this meter stick that's up here and get a little over a meter. Okay, you don't have to measure it in any kind of, yeah. All right, so just get a little over a meter. And then you're going to have to find a place in the classroom that's got an elevation that's a little above a meter. So the counter over there and this one are a little under a meter, so you need to stack a couple books. Then all these cabinets are labeled. Eventually you're going to use all of this stuff. Okay, but you're going to come over here and this box right here has got steel marbles in it. Alright, so go ahead and get yourself a steel marble. And how about we'll just set them out here on the counter. And you're going to tape this onto your steel marble. Okay, so get some tape. And just tape that on there. And then you have to feed it backwards through the machine. Or you can feed it through and then tape it on. That'd probably be smarter. Alright, but okay, you're going to feed that through. Like so. With it off, of course, or it's going to make a bunch of random dots. And you're just going to hold it like that. Okay? Now don't be doing this, because can you hold that steady? No. Okay, it's got to be on some books, and you want the machine over the edge because you don't want it to hit anything on the way down. You want it to be in free fall. Okay, that's what we're studying next. So do that, and then turn it on. It'll make a bunch of dots in the same place. And that's all your data. You're done. How easy is that?
Easy.
So easy. Okay, any questions so far?
Nope.
Make sense? Okay, Caden?
So, in a vacuum, why does
We will get to that. Okay, that is coming. What happens in a vacuum? Okay, you're starting to think of extension questions past what we're doing, and that's great. That's going to be in the PowerPoint next week. Okay? Sometimes I'll give you guys a lab, then I'll teach you the stuff. Sometimes I'll teach you the stuff, and then I'll give you labs on the stuff. It just depends on what we're doing. Okay? I like you to sometimes have a context for what we're doing before we talk about it on the PowerPoint. Alright? Then, wherever those dark dots are, you're going to go to your meter stick, and as best you can, you're just going to go like that and tear that off there. Okay, then you can put this back. We don't need it at all for the rest of the time. We're going to tape that. So get some tape and tape it on your meter stick. And tape it so that you can still see all the markings. Okay, so that, kind of like that, would be a good way to do it. And again, you're going to be using the metal meter sticks. Okay, so you're going to tape it on like that. And then we have a really easy way to get our distance time data. Okay, what tells us the time? the dots. So you're going to have a column, and I did a sample data table for you at the bottom. You're going to have 1 through whatever, as many dots as you get for that meter. And then you're going to do cumulative millimeter distances. In other words, not how far the dots are apart, how far the dots are from where? From 0. Okay, so you're going to record the distances from here, okay, for every dot. So your last dot may be way out here at 998 millimeters, okay, because there's 1,000 millimeters here, right? Okay, then we can easily do a distance time graph. Okay, we can just graph those two columns. After that, we're going to do a velocity time graph. And we're going to use each spacing. So I have my little dots here, and they space out more and more. Okay, what is this time period right here?
1 second.
1 dot. Okay, that's 1 dot. Now let's say this is 3 millimeters of spacing from here to here. Okay, how fast on average is that going during this time period? It's 3 millimeters per dot. Okay, not squared, all right? Okay, 3 millimeters per dot. All right, now, right here, let's say this is going 8, let's say this is 8 millimeters. How fast on average was the ball going for this little time period? 8 millimeters per dot. Let's say this is 20 millimeters. How fast was it going? 20 millimeters per dot. Now, was it speeding up in this time period? Yes, so the 20 is the average speed for that little time period. Okay? Alright, so that you're going to get all those speeds. So on the data table, okay, on the data table there, you're going to, all you have to do is subtract the 2 spacings that are consecutive to each other. And then you have your speed. Because they're all over 1 dot. Alright? Look at my, study my sample chart and it will make sense. Okay? We'll get to that. We'll get to that. Okay, now what's the point of the lab again?
To find out how fast gravity falls.
Okay, to find out it's to find out about gravity. So specifically, we want the acceleration due to gravity. So you need to think about which graph is going to get you acceleration and what about that graph is going to get you acceleration. Okay? So, you can either do this on the computer, and I left you instructions of how to use a program called Logger Pro that is on every laptop and every desktop in the whole school. You can do it that way, and that will make it really, really fast. Okay, you just follow those instructions. If you would like to do it by hand, you can graph it by hand, and you can get your slope by plugging your points into your calculator. Okay? You have 2 options, so that doesn't have instructions because you guys all know how to do that. Alright, now this is going to be our first, well, no, this is not. We're going to do this as a CER. Let's do a CER. So claim, you got your evidence, and your reasoning is going to be really short, guys. I mean, how, is there a lot of depth to this? No. You're just, but I want you to talk about the shapes of the 2 graphs you get. That's important. Okay, think about what those graphs should look like. Is the slope positive? Is it negative? Is it curved? Is there a certain shape that each graph will have? Right? Mr. Miller said he could maybe share some of the computers with us this hour if you want to do this part, okay, on the computer. If not, you can do it whenever. All right, let's make this lab do, how about next block? have a whole week to finish it. Okay, so that gives you time to get into one of the labs and computerize it, or you can do it by hand right here in class today and get it done. Okay? Then we'll move on to these other things. Alright, I think that's all. I'll put out some more tape dispensers here so we have those, but leave them up here so other groups aren't looking for the tape. Okay, and I'm just going to let you guys kind of go. No groups bigger than 4 today. Alright? So threes, pairs are great for this lab. I would recommend just working pairs. Okay? But if you want a group of 4, that's fine too. Everybody's got to have their own reporting data. Okay, you can stop. Alright?
That was